My name is Ken Finnegan. I am the co-founder and co-lead of WildFly Swarm, which is one of the projects that is part of RAW, which is a lovely acronym that stands for Red Hat OpenShift Application Runtimes. It just rolls off the tongue really nicely. So I'm going to be talking about WildFly Swarm today, and let's see if I can... That's a bit better, hopefully. So to start off with, we've all implemented an Elizabethan insult service, which consists of a noun API microservice, a adjective microservice, and an insult microservice. So we have three microservices, the insult one calling the adjective and noun ones, and then we have a UI calling the insult one. So right here, I've just got the basic root POM for my Maven project, and we can see that I'm specifying the version as 700.redhat-8, which is essentially mapped to 700, which is the GA version that was part of RAW that came out in December last year. And we can see we have the modules for the adjective, noun, and I basically just set up some basic stuff. So here I have like the WildFly Swarm plugin, and we just define the goal for package. And I realize I should have said that for those that aren't aware, WildFly Swarm uses Java EE. I just realized that. Getting ahead of myself a bit. And as part of this, we have a Fabricate Maven plugin here, because everything I'm doing today, I'm going to be doing in what we call Minishift, which is a local OpenShift environment that I can run from the command line, and it runs everything as if it was in the cloud. So in terms of dependencies, I've imported the main BOM for the product here, and then we have what we call a BOM certified, which are for some items that aren't fully supported, but we will certainly help with if there are issues. And then at the bottom here, I've just got the Red Hat repositories for Maven to pull those in. So if we start out with the noun service, and so obviously, we have to have a, wrong way, there we go. We have to have a noun, so we have a basic class that just has a string on it, which is fairly simple. The application defines an endpoint for noun, and this is the JAX-RS root entry point to the microservice. And you can see we're extending the JAX-RS application class here. And then we define a noun resource, which we're saying is going to act directly on the root, so it's just got a slash path. We've also converted this to a CDI bean, so we use the application scoped. And the advertise I'll get to in a second, but basically our post construct of the bean for JAX-RS will load in a whole bunch of nouns from a text file, and we have a simple get endpoint that produces JSON. And all we're doing is randomly choosing an entry from the array that we have. We have an add noun, which is a post on the same endpoint, which consumes and produces JSON. And we've just got some things in here to check that we're not trying to add an entry that already exists and returning a conflict if we do. One difference with this one is that the method returns the JAX-RS response object as opposed to noun. That enables us to do these kind of calls where we can set the specific HTTP response code as opposed to returning values or exceptions. And then here we add the noun to the already list that we have, and then we return a created status. And then of course the last one here is a delete, and taking a path, the noun on the path, and then checking if it exists before trying to delete it from the list. And then that just returns a no content response. So that's the kind of the APIs for the noun. I'll just quickly duck back to what we have for the POM for that. So for this, we're using the microprofile fraction from Swarm. The current microprofile version in product for Swarm is 1.0. So essentially that just combines CDI, JAX-RS, JSONP. I think that's it. That's all I can remember. In more recent versions of WildFly Swarm in community, We're currently supporting microprofile 1.2, which includes things like fault tolerance, config, what else is there? JWT, health metrics, health checks, and we're on our way to implementing 1.3, which was released by Eclipse Microprofile at the end of December. Those will make their way into future WildFly Swarm product versions. Talk to product management about when that exactly is going to happen. But we use the microprofile fraction here. We also use the monitor fraction, which at the time this was released is equivalent to the microprofile health check. It basically just gives you a health endpoint that you can hit when you're using containers, so the container knows that your application is live and working. And here we use Topology Openshift. Now, this is a WildFly Swarm homegrown service discovery mechanism. Now, obviously, in the world of Kubernetes and OpenShift, that's less important because you can reference things by name. But sometimes it's handy to be able to just do lookups and to hook into other things. So this is where the @advertise comes into play. And we're saying we want to advertise this endpoint under the name noun so that we can look it up from another microservice to retrieve it. And you can see here we just have the resources, which contains all the nouns. So I've got my local OpenShift running, so if I start up the console, at the moment we've got nothing in the project. So if I go back over to here, and which one is it? That one. And I'll do a Maven Fabricate deploy, which uses the Fabricate plugin to deploy my service to OpenShift inside the container. So it's just doing a build of Swarm there. And in a second, so it's starting a build on OpenShift. So if we go over here, we can have a look and we should see, yep, we've got a new build of noun occurring, which has been running for a few seconds. And we should see that the command line will finish here in a second, and we can go back and see it running in the OpenShift console. Okay. Okay, so it's running, and we can see it's running over here. It's still going through its deployment phase, which means that it's starting the service, but it hasn't reached a point, and we can look at the logs to see that. So it's waiting for the pod to become ready, and what that means, and now it's ready. So what it was doing there is, if we go back to the logs for the actual pod, we can see down the bottom here, WildFly Swarm is ready. It's a little small, but it's there. What that means is that we're ready to accept HTTP requests on anything that was deployed in that container. If we go into our deployment here and look at the configuration, we can see, that's better. We can see it define some readiness and liveness probes on the /health endpoint. And that's what the container is using to know whether the deployment is ready to accept requests. And all we did for that was add the monitor fraction and then create this simple, for this instance, health check where we use the @health annotation, and we specify it's going to be on the /health, and we basically just saying it's a status, and here's some details that we're up. So we can actually go see what that looks like.
Readiness is not different?
Sorry?
So liveness is that, or is it both?
For this instance, it's both, but you could have different endpoints for readiness and liveliness. And the way I've got the Fabricate plugin configured is that it's just creating things based on what it finds. I could have defined YAML to say this is the endpoint for readiness and this is how frequently you hit it and things like that. So if we open this up over here, it's forbidden because there's nothing on the root. And if we go to /health, oops, that's basically what the health endpoint returns. That's better. Which isn't a whole lot, but essentially the container is just checking for the 200 response code on that. Now if we switch over to Postman, and that's somewhat readable for the most part. So if I have a get noun test here, so if I click ascend on that, you can see it came back with codpiece. It's a lovely first response. And we can continually hit that and get different responses back. So that's telling us that the noun service is working. We can also try adding a noun. So I've got a body here of chili bear and passing an application JSON header. And if I send that across, I get a 201 response that it was created. And then we can also try deleting that again. So I've got /chilibear on the URL up there. I hit that, and it returns no content 204, which means it worked. And if we try that again, we get a 404 not found, which is what we'd expect. And likewise, if we added the noun again, that'll work. And if we try adding again, we get a 409 conflict. So that's telling us that the endpoints are all working as we expect. So let's have a look at the next one, which is adjective. It's fairly similar to noun, so I won't go into too much detail on it. Essentially, it's virtually the same, except a different set of lists in terms of the data being read and stored. It's all the same endpoint definitions. It's essentially the same code. It's just different variable names. So if we deploy that across to Fabric 8, well, with Fabric 8 rather. Yeah. Oh, not undeploy. There. So while that's deploying, we'll have a look at the insult service. So the insult service has a bit more to it. So we have a model where we just have a name, which is we can insult someone in particular, so we need a name object for data passed in. And then we return an insult which consists of a noun, and two adjectives, and a name if there was one. Now, what we've done here is I've used, for each of the adjective and noun services that we want to interact with from insult, I've defined an interface which is essentially the JAX-RS endpoint that is the external service I want to hit. Now, the reason I've done that is that that's the adjective service, and what that allows me to do is inside the resource for this, which one is it? That one. So these 3 lines here, what we're doing is we're using the REST Easy Client Builder, which is the JAX-RS implementation for the JBoss, and we're building a client. We're telling it the URL of the service we want to hit, which I'll get back to in a second, and then we're saying proxy the service interface we defined, which then allows us to call the service with a method as if it was a local call. So as far as our code is concerned, we don't have to deal with HTTP requests or client responses or anything like that. REST Easy handles it through its proxy. And in terms of the service URL, all we're doing up here is saying get the service using the name noun. And what this does is it uses the topology map of services that have been registered against the instances and looks for that name and then returns the URL of that instance. For Openshift, it doesn't add a huge amount of value, but it's still kind of nice to be able to do this anyway. And then it means it's runnable across other environments that might use console or other means of service discovery, and the code doesn't have to be altered. Let's see. So adjective is deployed. Now if we do, we'll do the insult one. So the insult service, we can do a get insult without any name, and then we'll just pass a null into the insult by name to get nice code reuse. So what we do is we create a client for the noun service and one for the adjective, and then basically I return a new insult object setting the noun to the response of that service and the adjective calling it twice to the response there, and then just returning the name if we've got one. So it's all pretty straightforward. Let's see what that's, so that's deployed. So if we go back to Openshift, so the insult service is currently doing its rolling deployment, so it should be done in a second. Okay, that's up. Now if we head over to Postman and do a get insult call, we can see it's returned a noun, 2 adjectives, and an empty name because I didn't pass it one. And if we do an insult by name, and we'll insult Jeremy. So if we send that off, and we get another one back with the noun and 2 adjectives and his name again. So all the microservices are working as we expect. So now we can quickly have a quick look at a very simple UI here, which was built by Lance and I stole. So we can just hit the insult me button, and we can see there the insult it returned on the right. And if we enter a name, we'll insult Steve this time. So now we can see we get a different insult for Steve, and we can keep insulting Steve as many times as we want, and then we can say, really sorry, Steve, I'll clear all those up for you. So that's kind of the services working as they are. And one thing I think I have time to show is circuit breaking. So that's a fairly important concept, and what we have in this service is, let me just show you down here. So for this, the insult service, we can add Hystrix as a dependency, which is part of the BOM certified. So it's not something we support fully, but something we certainly use and offer. So with Hystrix, I'm able to create a Hystrix command which handles the noun. And so this is the constructor here is just defining a group key for Hystrix and some properties for like request volume threshold, the sleep window, error percentage, things like that. There are 1,000,001 ways to configure Hystrix in different values. It's very confusing. And then basically the run method here is still using the same proxy we had before, but it's part of a run method here, so it can handle it. And then the fallback, we've just got a fallback noun to be returned. So how do we use that? If we go back to the service over here, all we have to do is change this to say, and what is it? Noun service URL dot execute dot get noun. So we've just changed that one line, and we've gone from interacting with the proxy directly to interacting through Hystrix, so it can handle errors for us. So if we now redeploy that to Openshift, that'll just take a second. While we're doing that, I will start up a Hystrix dashboard so we can have a look at that at the same time. So, let's see, Hystrix dashboard. Hystrix dashboard, okay. So that's the main page of the Hystrix dashboard. Is that deployed yet? Okay. Let's have a look. Where are we? Over here. So that's doing the rolling deployment now. We'll just give it a second. Okay, that's up. And what we can do with that up is by adding the Hystrix dependency to our project. Not only do we get access to the commands to create circuit breakers, but we activate the Hystrix stream, which at the moment is showing nothing because everything's working fine, or rather no data is passed through it. So if we send one of these through again, we can see that it's still working here, but we can now see we've got data in the Hystrix stream, which can be interpreted by the dashboard. So if we take a copy of that, and we just say we're going to monitor that stream. So that's the Hystrix dashboard view of that particular command we wrote. And if we head back over here and hit that a couple of times, we can see that we've had 4 responses come through and everything's working as we expect. So what we can do now is scale down the noun service to simulate a failure of some kind. So it's now no longer there. And that still thinks everything's okay, but if we make a request through here, we can see now that we're getting fallback noun as the noun name. And if we go across here, we can see that the circuit is still closed, but if we hit it a couple of times, I think it'll, how many, I think it's, maybe it's 10. And we keep hitting it.
It's a rolling percentile.
Yeah. There we go. Now it's open. So we can see the circuit's now open and all requests are now going straight to the fallback without even trying. And then we can reactivate the pod, scale it back up. Are there any questions while I'm waiting for this? Yes?
So is Hystrix only on the instance service?
Yes, Hystrix, the stream servlet is only active on the insult servlet service because that's where we're using Hystrix.
So noun is only being accessed, or Hystrix can only know about noun through insult?
Right, yes, so as far as noun is concerned, it's not being used as part of a circuit breaker and it doesn't need to know it's being used.
So when the service comes back up and it's on 100% fallback, how does Hystrix know that now the service is back?
It hits a timeout threshold for retrying, so that I think it's been a while since I've remembered how all these work, but I think, yeah,
10 seconds.
Yeah, so every 10 seconds it'll try again, and if it gets through, it'll then close the circuit, but if it doesn't, then it goes back to using the fallback. So let's just check that's up. Let's check get noun is working. So that's working again, and let's try the UI now. And that gave us a response that's valid, and we should see the Hystrix now is closed and everything's hunky-dory again. So that was a very whirlwind tour through WildFly Swarm as part of RAW, and circuit breaking, JAX-RS endpoints, health checks, and probably some other things I forgot in there as well. If you want to learn more about WildFly Swarm, there's a website which is mostly community focused, but there'll still be links there that'll be valuable for product. WildFly Swarm, -swarm.io. That's me at Ken Finnegan on Twitter. And as Jeremy mentioned, I'm in the process of writing a book, Enterprise Java Microservices, which should be out whenever I finish it, hopefully over the next month or two. I'll at least finish writing it, and then whenever Manning does their magic and then prints things out. And I think that's about all it from me. Brian, I think. Yep. Are there any other questions while we're switching over?
So if there are 2 instances of now, if one goes down, would Hystrix be able to sort of just communicate with one and go down?
Yes, so the way that works is because we're using the topology to look up the services, and because of the way Openshift does load balancing, it's hitting the same name and it load balances across the instances. So if there's 5, it'll load balance across those 5, and if 3 of them disappear, it'll just load balance across the 2 that are left. And as far as Hystrix is concerned, it's just hitting the same endpoint. It's just a load balanced endpoint.
Hi, so my name is Brian Ashburn. I'm a senior solutions architect with Red Hat, working here in the Southeast. And so the one that I ended up getting was Spring Boot. So I've got a microservice here, and of course, one thing I've learned in working through this is that if you ask a question to 4 Red Hatters, you're going to get about 6 or 7 different answers. So each of us have done a little different thing and focused on some different stuff. A couple of the things I'm going to talk about today will be how this fits into some testing. So I'll show you some of the test cases. That, to me, is one of the nice things about Spring. It brings a lot of test facilities, so we'll take a look at what that will look like. And then we'll take a look at what a circuit breaker as well looks like whenever we're doing this with Spring Boot. So the first thing we have here is this main parent POM that's got some dependency management in it. It's using the BOM from Snowdrop, which gets us all of our cool Spring Boot stuff. We've got our Spring Boot Maven plugin. And then, let's see. So let's take a look at an endpoint test. So I've got an endpoint called adjective that actually takes both of the adjectives and returns them as 1. Inside of that, I actually, in the first call to it, it's going to return successful. The second call to it's going to return a 500. And that way I can mix in some errors, work with this as there are. So what I did was I built me a small unit test. We annotate it with the Spring Boot test here at the top, grabbing the port since we're going to use a random port for it. And then I'm using rest assured in order to hit that. So here, the nice thing about rest assured is that it's that when-then kind of behavioral definition. So when we hit that adjective, we expect to get a 200 and a not null value. When we hit it the second time, we're going to expect it to get a 500. So IntelliJ, Alt-Shift F10, run our little test here. What it's going to do then is it's going to start Spring Boot up. It's going to deploy this application in it, and then it's going to go through and run those tests. And as we see, it came back successful, which hopefully that's the case since I just ran it. All right. So let's take a look at that endpoint. First, we'll take a look at the application real quick. The only thing we have to do is add the @Spring Boot application onto it. This is what's going to tell Spring Boot that this project is made up of Spring Boot components. Let's see. There we go. So here we look at a REST controller. This is where we're implementing it. So we just have an annotation for a request mapping, giving it the API URL that's coming through. I've created a class called adjective source. This is what reads from those text files in order to get the adjectives, and also do some random number generation on that. I actually wrote that so that I could test it as well. And here I've got a fail switch that's going to switch off back and forth every time it gets called. Now here we're returning a response entity. That's going to contain the string as well as the HTTP status for that particular call. So let's see. All right, let's take a look at a couple more things before we go over to start to run this. Next is going to be the actual insult service that's going to call the adjective service. Now, the adjective service on this project is wrapped in a Hystrix controller, which we can see here, very similar to what he was just talking about. We have our Hystrix command. We give it a fallback method, and then that fallback method is going to return 2 strings. So instead of returning something Elizabethan, I return something a little bit more technical, that it's unconnected and non-distributed. So here we're passing this service in, and we're allowing Spring to do everything for us, right? We're just passing it into the constructor. That way it's final. We can do all of our cool things like that. And then when we return back that insult object, it's going to transform that into JSON in order to get back to our final request. All right, so next thing we're going to do is come over here. I've got Minishift running. So we're going to take and deploy this application, hopefully, to Openshift. Oh, hold on. New project. There we go. Got to make sure we got a project for it to deploy into. So that's going to run through. It's going to run through all of our tests, make sure that everything gets tested, passes, before it actually goes through and does the deployment out to Openshift. And I didn't go through and create a nice little UI. Everything that I have is all kind of curl-based. But we'll take a look at what those things are in just a second.
So are you bypassing the Docker build and basically if you maybe get into the runtime, application runtime, that it actually recognizes the Java?
Right. So yeah. So this is using the S2I process, the source to image process, in order to build whatever service the Docker containers or the Docker images that are going to be needed by this. And so that's the fabricate deploy piece. That is going to knows how to make those calls into OpenShift in order to create that S2I. So as we can see, it's created the adjective service as well as the insult service. The adjective service is already up, so we can come over here. And as we see, we call test adjective. We get a string back. First one being 2 adjectives, the next one being that error message. Now we see that the insult service is up. Now, one of the things here, and I did this on purpose, because I actually, when I was writing this, ran into this problem. So we see that we're seeing the error inside of the insult service here. The reason why is because I left an annotation off, like I said, intentionally, so that we could take a look at what that was. The way that you take and apply the circuit breaker is actually we just add an annotation to our Spring Boot application telling it to enable the circuit breaker. And now whenever I rebuild and redeploy, it's going to be able to start using that circuit breaker in there. So if we flip back over here, just hit up and rerun our deployment. What that'll do is that'll go through and rebuild everything with the circuit breaker enabled and get it deployed up there. We'll then be able to test we'll take a look at the adjective and see that service is coming back. We'll still come back with the errors, but if we look at the one below it, it's always going to have an adequate value within it. Let's see. Any questions so far? I know I'm moving a little fast. I wasn't sure how much thunder he was going to steal with the circuit breaker. I'm sorry, say it again?
Can you configure the circuit breaker once the application is already up and running?
No, you've got to have that enable circuit breaker annotation on there, so you're going to have to build and deploy it. The nice thing is that it's going to build, and as you can see, it's doing a rolling deployment from this. So if during all of this I was hitting that service, the services are still going to be up. Nothing's down. It's just I'm not going to get that next version until it finishes with this rolling deployment. We can actually try to test that right now, maybe. Well. Oh, might be it. See, so now as we can see, if we take a look over here, I'm trying to get this a little bigger. The unconnected, non-distributed is the failure scenario. That's my default. So when we hit it and we get an actual adjective, that's whenever it's succeeding. This one is where we've gotten a 500. And then I'll do what he did, because I was planning on doing that as well, which is we'll bring this pod down. Yes. So now that pod is down, as you see, we're getting some big error up here. But if we come down to the insult service, it's always going to be able to come back. Now it's giving us just a default adjective. We can make that very easily, do something a little bit extra from that. And at the end of the day, it really is just a Java method on a Java class. That was one of the big things that I noticed about doing this, that is kind of one of those main things within Spring, is that everything is a plain old Java object, right? There's not even a whole lot of extra annotations or anything that can't be ignored. So that really gives you the ability to get in and do true unit testing and real kind of testing on this, and slowly add those layers onto it as you build that up.
So when you're deploying that pod, how many different services are you deploying?
So I've got two different services that are being deployed. Inside of one of those, I've got a couple different REST services. So in the insult one, I've got two different REST services, one for the noun, one for the insult, and then I've got one for the adjective.
So where does Hystrix live?
So Hystrix lives on the service that's going to make the call into another service, right? So the insult one is going to have to call in order to get the adjective, and so it has to plan for failure. It has to say, I don't know if that adjective service is going to be up and available to me, so I need to take some precautions ahead of time so my end users don't have to deal with the problem.
So if you're not making a nested call, you don't really need Hystrix.
Correct, right? If you're just doing everything within that service, then hopefully, if anything fails, it is that actual service that's failing. So you're going to want to, especially as you start getting into microservices and getting things a lot more fine-grained, you're going to find that a lot of your microservices will start to grow as composites of other services. But when you start getting to that stage, you're definitely going to want to put these types of things in place because you've got so many pieces of connection, or so many different connection pieces that could fail, and you don't want that to mess up the service, right? It's like we say a lot, right? Distributed computing is hard, so once you get into that part, that's really where you've got to get that thing built in. Any other questions? All right. Thank you. Mine went pretty quick. We have Node.js next.
Hey, everybody. While we're getting set up, I just want to get a sense from you guys. I mean, obviously, Red Hat is thought of in many ways as a Java company. How many of you here are doing anything with JavaScript on the back end? Node.js, primarily? Anyone thinking about it in the future? Okay, well, I'm going to show you some cool stuff. Let me just get this stuff set up here real quick. Maybe. So it says I'm mirroring the display here. It takes a second? Okay. Tell me what I should be. I can put it at 1080p?
It was all planned.
There we go. There you go. Okay.
Yay.
All right.
And there was much rejoicing.
Okay. Let's see. I have slides. At least a few anyway. So my name is Lance. I'm a principal software engineer at Red Hat. I work in a group called Project Odd, and what I've done for about the last 7 years is sort of do research and prototyping into other technologies outside of the Java world to see sort of from all these things that are up and coming, where can we integrate those with our best-of-breed Java technologies. And lately it's been Node.js. I've been working on Node.js type of stuff for about 2 years. I actually implemented Node on the JVM and didn't work very well, but it was a fun research experiment. And so what I'm here to say in some ways is that Node.js is really a thing at Red Hat. It's not a huge thing yet, but it is a thing at Red Hat, and I know some people might sort of think, what? But it's true. And these are some of the things that we're working on, and you're going to see all of this today in the Shootout, or at least my implementation of it. We've got runtime containers that run on Openshift. We do integration with existing Red Hat middleware. We have our own implementation of things like circuit breakers, which you've already heard about a little bit from the Java world. I'll show you what that looks like in JavaScript as well. We also do some tools and utilities and things like that for DevOps because, getting these applications, whether they're Java or JavaScript or Ruby or whatever, getting these things into a cloud-based container-like environment can sometimes be difficult and time-consuming, so we put together some tools for that. And as well as all of that, we've got a couple of contributors to Node.js Core, myself included. And one of the guys that I work with is on the Node.js Technical Steering Committee. So we're making a real effort to have a presence within the Node.js world and Node.js ecosystem, and that's a big part of what I'm doing here today. So, but why? Right? Well, today, this morning, I don't know if any of you saw Christian's talk. I thought it was really interesting because he said a lot of the same things that I've been thinking about lately, and that is that, as the platform that you're running your applications on gets a lot more complex, right? And the applications get a lot simpler because microservices, they don't simplify your applications. They just move the complexity from the application itself to the runtime environment. So that shifting complexity means that it might be possible to take advantage of a lighter weight or maybe less mature runtime, and Node.js kind of fits that bill. So everyone kind of talked about the application that they've implemented, and this is pretty much what it looks like in a diagram. You've got the browser that connects to the insult service, and then the insult service connects to an adjective service and a noun service. It works just the same in Node.js, right? The one thing that I wanted to point out, though, is that because it's all JavaScript, the circuit breaker that we've implemented for the back end will also work well on the front end, which is kind of neat. I'll show you that in a bit, too. So let's try some things. Wow, everything got really small. Actually, let's open up this. Okay, how's that font size? Is that okay? Can everyone see that all right? Okay, so first of all, I want to talk a little bit about the deployment of this application. There's a couple of different ways we can deploy it. I've just got a couple of scripts here. One of them just runs it on localhost by setting a separate port for each service, and another one will deploy it to Openshift. So let's do that real quick. Not localhost. Okay, so what this is doing is using a tool called NodeShift, which we developed. And it takes a look at, you don't have to have the Kubernetes YAML files there, and in fact we only really require sort of bits and pieces of them. But that YAML metadata, it takes a look at in your application source code and then deploys this Node.js application to Openshift. And in this case I'm just deploying to Minishift. It's doing some kind of interesting things here. We're taking advantage of some of the other technologies that we built, like a license reporter. So during the build process, it looks at all of the dependencies that your runtime has, identifies the licenses for all those dependencies, and then creates a report that you can serve statically from your website. So let me just bring up the application here real quick. Well, I guess I'll have to wait until it's fully deployed. So this is my Minishift console running on my machine, and as you can see, we have all of these services here. It's still in the process of deploying them. But just like the screens that you've already seen a couple of times, we've got an adjective service, an insult service, and a noun service. The insult service is currently being deployed, but it is running a rolling deployment like those other ones were, so we can actually probably bring it up. Yes, without a problem. My UI looks slightly different because I modified it a little bit after Ken copied it. But you've seen this, right? This is just like you can get insulted, thou burly-boned, fly-bitten wayface, or whatever. And you can add a name. If I can spell, I really don't like this new keyboard. So we can call Jeremy some names. It's pretty straightforward. We have the API documentation through Swagger. That's been mentioned, I believe, a couple of times today. So you can actually use this. This can be used in a similar way to the testing tool Postman that Ken was using earlier. With your Swagger API definition, you can just try out your service and see whether or not it is working fine. So we'll execute that, and we see that we get back an insult, perhaps. Well, okay. I'm not seeing the response. We also have health check services. Let's just move on. We also have health check services that were mentioned earlier. And if we go back to the configuration for this service, we can see that those health services are specified as /API/health on port 8080. That's a readiness probe and a liveness probe. So as you can see, this is all pretty much exactly, it looks and behaves exactly the same as the Java stuff. So let's look at some of the code. I assume most of you guys and gals are Java developers, so I will take it slow, not too slow though. Let's start with the easy stuff. The noun service doesn't do anything except for read a text file and return a JSON document that consists of a noun. And it's pretty straightforward. I'm using Express.js to handle HTTP. And I specify a get and a post function. And on the get function, I get a noun from the database and provide that as part of my response. And this is my response here. I specify a post, and I look for the thing that was posted in the request body. And send a status, and then I can also delete a noun if I find one. And this is the full extent of the noun API itself. The thing that wires that all together is pretty straightforward as well. We're using Express. This is all I need to do in order to get those Swagger API documents in place, is to use this Swagger UI module. And I add that down here as just static documents. That are based on a JSON document that describes the service. I specify using this Kubernetes probe, kube probe, what our health endpoints are. In this case, I'm only specifying the liveness URL, but I can specify the readiness URL as well, API health. And then if I look at the JSON file that describes this deployment, you can see, this is just a Swagger or OpenAPI JSON file. All right. So let's look at insult, because insult will show a couple of things that I think are kind of interesting. The main thing really is the use of circuit breakers. So we're using this circuit breaker in the insult service. It's actually... Sorry, bear with me one moment. Right. I did a little refactoring the night before last and forgot. So I created a couple of JavaScript files called adjective service and noun service that the insult service use, right? So the insult service uses this thing called promises. Anyone here familiar with JavaScript promises? A few, yay. Promise is basically just a promise, represents a future result of some execution, right? And it can either be successful or a failure. And so the way we express our promise or use our promise is this function build insult will return a promise. And when that promise resolves, the then function gets called with the thing that is returned from that promise, in this case, the insult. We send the insult, and if there is an error, then the catch function gets executed. It's fairly straightforward. It's a very nice way of dealing with asynchronous execution in JavaScript environment. If you've ever heard of or experienced callback hell, yeah, that's the goal is to eliminate that as much as possible. So promises do that for you. All right, let me look at adjective service. So the noun service, actually, real quick, I'll go back and look at this build insult function. So this build insult function takes 3 promises. The response from adjective service call number 1, the response from adjective service call number 2, and the response from the noun service. And then once those have all resolved, it constructs this JSON document. Well, actually, it's just a JavaScript object that gets turned into a JSON document. That consists of an adjective, and a noun. If for some reason all of those promises don't resolve, then the catch function is executed, but we won't see that. Okay, so let's look at adjective service. So the adjective service is something, it's kind of weirdly named. It's the client, right? In this case, this is the insult services adjective client, calling out to adjective. It's using a networking library called RLI. It's using Opossum for circuit breaker. And we just build up, what the service is here. The nice thing about Openshift is that using the Kubernetes YAML that I mentioned earlier, we can specify what the service name is. And so in this case, it's just called adjective. And so we can look it up just using the host name adjective. Which is pretty nice. So this is the creation of the circuit. When I call the adjective service, I've got some options here that I can specify on my circuit. How bad does it have to be broken before you actually start failing fast? Open the circuit, and then some fallback function. There are some fallback values in case it does fail. So what I do here is I specify that we've got this circuit. It consists of, this is sort of newish JavaScript syntax. It consists of this arrow function that basically makes a network call to the service URL. It returns a promise. And in the event of a failure, we're just going to write out to the console. When the fallback occurs, that is an error, so we'll see something on the console as well. But we'll also want to return some sort of fallback value. So we've got the fallback values up there, beetle-headed, wart-necked, whatever. I pulled these out of the text file. And we just send that as a stringified JSON file. Parse response is just parsing the response that comes back from the adjective service. So that's really it. Really simple, really straightforward. So let's see what that looks like, how that behaves. I want to show you one thing here. So we saw what happens when you try to bring down the one of the services on the back end, like the adjective service or whatever, and we get some default value back. But also because I think it's kind of fun, I put this into the HTML as well, the circuit breaker, and I'll show you the code for that real quick, and then I'll relinquish the podium. So here in the HTML document, we have this function called getter post insult. which will return the value of get insult, or if the user hasn't provided a name, it returns the value of get insult. If the user's provided a name, it grabs that name and returns the value of post insult. And I set up my circuit breaker down here by saying, you know, the function that you call is get or post insult. I've got some options for it, and I have some fallback function here. Some various things to do when the circuit either fails or rejects or opens. So if I go back here to the Openshift web console and actually just scale down the front end completely, which I can never remember where I go to do that.
Expand the section.
There we go. All right, it's going to get mad at me. It doesn't want me to scale it down because there's no more pods being served. But my web page should still work fine. If I click insult me, now it's just insulting the server administrator because he's slacked off or she is slacked off and brought the service down. So we have a circuit breaking on the front end as well. And if we bring that back up, sorry, can you repeat the question? What is the purpose of the circuit? Well, the purpose of the circuit breaker pattern is the fact that in many instances, you're doing something that might fail, right? You're making some sort of network call or something like that. And if you're making a network call that could potentially fail, you'd rather have some sort of graceful response than a failure, right? So with the circuit breaker, what you can do is you can specify, well, if it does fail, here are some fallback values that you can return. You can specify some sort of action that can be run on the back end, like, you know, notify a server administrator. It also has the nice effect of being able to do what you kind of call like client scaling. The client itself can scale back when it notices that, you know, problems keep occurring. It scales back by opening the circuit, and then it'll, you know, gently, as Ken described, test to see after some timeout period, you know, will that network connection work again? If it does, it, you know, closes the circuit and everything continues normally. If it doesn't, it backs off again for another 10 seconds. And there's a lot of configuration that you can apply to. I'm sure Hystrix's circuit breaker, probably way more than you can to mine, but you know, there's a lot of variables that you can take into account with, you know, what kind of behavior you want your application to have in the event of a failure. Yeah.
Yeah, it's particularly beneficial for, and the reason Netflix came up with it was the whole idea that if you've got like multiple chains of microservices calling each other, if the one at the very bottom fails, you just get a cascading failure all the way back up and everything starts dying. At least if the very end dies, the next one up in the chain can say, okay, it's died, here's what I'm going to do instead, and everything else can still act as if everything's okay.
Okay, so I think I've sort of very quickly covered a bunch of stuff here. If you're interested in the code, that's where it exists on GitHub /roar-shootout, and there are at least 3 of ours there. And then I also have these slides on my personal website, lanceball.com. Thank you.
Have your adapter. So, from my opinion, they saved the best for last. But I've got to kind of justify myself. It's late in the afternoon. You're all feeling a little sleepy after eating so well and hanging out in here all day. You've already seen we can do these microservices in Node.js, in WildFly Swarm, in Spring Boot. Why do we need Vert.X? Well, Vert.X adds some additional features that we didn't see in some of the others. So Node.js is a non-blocking API, which means that we don't have to worry about coordination of threads and worry about race conditions and things like that. But Node.js is single-threaded. So to scale Node.js, you have to run multiple Node.js processes, and then how do you coordinate those multiple processes? Vert.X, on the other hand, is based on the JVM. It is polyglot. You can write in JavaScript, Java, Groovy, Clojure, several others, all in the JVM. And it's multi-threaded with some single-threaded guarantees. So everything in Vert.X is represented by what they call verticals. And any given vertical, by default, is guaranteed to be run single-threaded at a time using non-blocking IOs. But if you have multiple verticals in an application, each of those verticals can run on separate threads, so you can actually utilize the entire capabilities of whatever hardware you're running on. And then to coordinate across those single-threaded verticals, it provides you with a message bus, an event bus, what they call. Going even further, Vert.X provides you with low-level support for clustering Vert.X instances, both locally within a single machine, across the network, in a platform as a service like Kubernetes or OpenShift, across cloud providers using the event bus bridges. So you could actually bridge the event bus from one data center in AWS to another data center in Google GCE or to Azure or to wherever, so that your application is truly distributed and can operate as if it's one application across multiple data centers. This statement here about Vert.X is probably the most important thing to remember is the word toolkit. Spring is a framework. Node.js is a platform. WildFly is an application server. Vert.X is a toolkit. It's a jar file. You could include it in any Java application you want. So if you're writing a Spring application and you want the Vert.X event bus to be able to coordinate across multiple Spring applications, add the jar. You got it. You want to use it in WildFly? Sure. You want to use it in your Java SE, your Java EE? Vert.X doesn't care. It's completely unopinionated. So that said, we can add reactive capabilities using the Vert.X toolkit to any Java app, or we can write an entire application from scratch using all of Vert.X's principles. These guys have already done a great job covering what our service does. What I'm going to kind of cover is a little more about the details of what's different in Vert.X. This is me, InfoSec812 on Twitter. This is where I work. I'm the only guy from Red Hat Consulting here. And our team is different within Red Hat Consulting. We don't sell product. We sell team services, people and processes. We help your developers become better developers. Feel free to catch me later, and we can talk about details. All of the code's up here on GitHub, as Lance was telling you. And one of the things that they weren't able to show you because they didn't get the early access login yet is Openshift Io, which we're going to be releasing at Summit this year. What, 4 months away now? And Openshift Io is a hosted OpenShift service with an integration of Codenvy and Eclipse Che, which is the online browser-based IDE, as well as boosters for all 4 of these platforms to run inside of OpenShift. So for example, I can go in here and create a new space and use a scenario-driven plan, and we'll call it test. And it will actually offer me the option to bootstrap a new application using a quick start in one of these tools. Swarm, Spring Boot, Vert.X. Node.js isn't up here yet, but it should be GA by the time Summit rolls around, right?
It's tech preview now.
Tech preview now.
Is
Later this year, hopefully.
Yeah.
So I can choose to create a Vert.X project right here from the HTTP booster, the health check booster. There are other boosters coming, and I've got them in my development preview, like the circuit breaker preview and so on. And it will, when you log into your OpenShift Io account, it connects to your GitHub profile, and when you create a new project, we're going to call this ATL microservices example 2018, 18. And it'll actually create the GitHub repository for me. It will load up the framework for the application into GitHub for me. It will set up webhooks within GitHub to tie in to the CI/CD pipeline that's built into Openshift Io, so that when I commit to the master branch on my repo, a build will automatically kick off. And as you can see, here's where you set up your deployment pipeline. And you can choose, do you just want to go direct to release? Do you want to have a staging environment before release? Or do you want to have staging, release, and approve and promote? And we'll choose all 3 steps and move on. And it gives us a name for the Jenkins space that it uses under the hood. Oh, there we go, finish. And when I finish this, it's going to spin up an actual OpenShift container inside of our platform as a service that runs Eclipse Che. Anybody here familiar with Eclipse Che? Anybody here heard of Codenvy? Okay, a couple more. Eclipse Che is an open source project to build an integrated development environment in a browser. And it's backed by all of the technology that runs the Eclipse IDE. And then Codenvy was a commercial offering that offered multi-tenant support for Che. Red Hat acquired Codenvy last year. We have completely open sourced that product and have started integrating it to our products. And so that's what you're going to get to see. And at this point, you can see that my pipeline is running. It's doing a build. And when it's done, it will allow me to go through that build. While that's running, I'm going to switch over and start showing you some of the code that I wrote for Vert.X. As mentioned before, the least common denominator, the smallest piece of work in a Vert.X world is called a vertical, misspelled intentionally, so that you can search for it on Google easily. Go, anybody? Tried to search for Go help on Google? And so you're going to see a lot of common things that we saw in some of the other discussions for the platforms. One of them is using promises. In Vert.X, we call them futures. And we create a future for doing my configuration retrieving. This is a method that retrieves my configuration for the application from OpenShift, from a config map. When that completes, I can then chain that to provision my HTTP router, and I chain the result of that to create my HTTP server, and I chain the result of that to say, okay, my vertical has successfully started. If any step in this fails, I can add a new line down here that says, oh, well, and of course, dot fail, and I can throw an error or whatnot. So as you can see, we start off by retrieving a configuration. And what I've got is Vert.X has a module for doing configuration retrieval, either from text files, directory servers, environment variables. It supports about 20 different options. This one, the default is to pull from a JSON file in the class path. That's useful, very helpful. And then if we detect that we're running inside of Kubernetes or OpenShift, we then pull a configuration from a config map in OpenShift, and it overlays. And the order of operations that you configure your config store is the order of precedence. So the first one defined will get overridden by the second one defined, which will get overridden by the third or fourth, however many you go. This is all non-blocking, and it doesn't actually stop anything in the JVM, which is why you'll see a lot of these interesting little futures coming out of. You'll see both handlers and futures a lot in Vert.X. Traditionally, Vert.X uses handlers. In other words, you're passing in a callback method or a callback class that then gets called at the end of an asynchronous operation. Going forward, around Vert.X 3.4 5.3 or Vert.X 3.6 in the near future, they're going to offer an alternate future-based approach so that you don't have to do callback hell, you can just do functional composition. And another thing you'll see is things like this. Does anybody recognize this syntax? No. But it does look like C++. This is the syntax for what's called a method reference in Java 8 and later. In Java 8, we added Lambda expressions. But with Lambda expressions, when you start nesting those, it gets very, very messy, very difficult to debug, very difficult to grok that code. So to clean that up, we can take the Lambda expression, put it in a method, and use this method reference. So this is actually saying call this create HTTP server with the default arguments that are provided by that Lambda or that functional interface. So that way we actually extract this functionality into a separate method that is now testable. And one thing you'll notice in my examples of Vert.X is I don't use dependency injection because I don't need to use dependency injection to do loose coupling and inject mock objects. I break them out into these method references, and I can just call that method directly from my test suite, providing a mock option as an argument, or a mock object as an argument. So we get the original configuration. When that completes, we start provisioning our API router. By default, Vert.X's HTTP routing is very similar to what Lance showed you in JavaScript. It looks very much like Express. It was designed to look very much like Express. In 3.5, they've added a new feature, and I kind of screwed myself up trying it out. Unfortunately, there's still a bug or two. And so you won't see me deploy my app to OpenShift because that bug prevents me from running it in OpenShift right now. But what it gives you is what they call their OpenAPI 3 router factory. And what that router factory does is it reads that Swagger or OpenAPI specification file and builds our route tree for us. So I don't have to write JAX-RS annotations. I don't have to write special functions to cover each and every method call and HTTP verb. I just pull in that Swagger specification. And once that's complete, in that Swagger specification, I have an operation ID for each operation, and I attach a method to handle each of those operations by name. Really quite simple to read, quite simple to understand. It almost becomes like reading a sentence. So I get an operation. If it's a get insult, this is how I handle it. If it's an insult by name, this is how I handle it, so on and so forth. How many of you are familiar with this syntax in Java? A couple of you have seen regular Java 8 lambdas. So this is a Java 8 lambda, but what you may not have seen before is chaining Java 8 lambdas. So we have a lambda that calls a function that is handled by another lambda. And the only reason we're chaining these instead of using method references is because we are passing several different arguments that can't be handled by a default method reference. So you see that we've got our get insult, we've got insult by name, and we've got a health check. In this case, on the noun service, the health check is calling what's called a service proxy in Vert.X. Now, I mentioned earlier Vert.X has an event bus, and the way that you coordinate across multiple verticals is with that event bus. But the standard way of talking on the event bus is like vertex.eventbus.sendMessage to this address with this object, so on and so forth, and it gets a little messy. To abstract that away, they introduced a concept called service proxies, where you write a service using an interface. And we see that it has two methods that come built in by default with Vert.X, which is the create method and the create proxy method. New insult service implementation Vert.X. Hey, look at that. I missed something in my code. And then we define interface methods for what we want to implement, which is get insult, named insult, and the health check. And when we look at the implementation, we fill in all of our logic there almost as if it's synchronous code. Looks very similar to our standard Java code. And it just implements that service. Then back in our main vertical, we bind that service to an address on the event bus. And so now anywhere in our application, in this Vert.X application, or in any other Vert.X application that is clustered with this one on the event bus, we can call the factory method for that service and just call it as if it's a local method, similar to what you saw with the REST Easy client that Ken was using. But it actually operates across the event bus and has isolation and is scalable. So we map those service proxy methods to our Swagger specifications, and we handle the results using callbacks, which I've specified as method references here. That's a lot to throw at you, but I want to ask anybody have any questions up till now? All right. Vert.X really, if you're writing a Vert.X application from scratch, it's a completely new programming paradigm for most of us coming from a Java background. It's relatively similar if you're coming from a Node or an Erlang background to how they operate. That said, we know that people already have an investment in time and understanding in other technologies, so Red Hat has produced another open source project called RedPipe, which abstracts a lot of the Vert.X style thought processes behind JAX-RS annotations. You still get access to all the capabilities of Vert.X, but you can write your original REST code using JAX-RS. Last thing I'm going to show you is how we configure a circuit breaker in Vert.X. In my implementation of my service proxy service, I have created several circuit breakers, one for the noun service, one for the adjective service, and you can see that I feed it in a config. That config is things like the maximum wait time for a service to respond, the maximum failures before we open the breaker, and the reset time. And then we also say that if the circuit breaker opens, we can add some logic. So for example, maybe we want to email our administrator and say, hey, this service that I rely on is down. I'm working around it for now, but you might want to look at that. And when the circuit breaker closes again, we can set a handler to do something, some sort of operation. Maybe it sends an all clear alert to your sysadmin or to your developers. Hopefully it's your developers if you're really doing DevOps. And then finally, you can specify a fallback. So if the circuit breaker is open and somebody makes a request, what's the default value we're going to return? And we use that by wrapping calls in this execute method. So we say circuit breaker.execute, and then we call a method inside of there, and it provides us with an instance of a future, and then that future is how we complete the asynchronous call. Questions there? One thing I will think is kind of neat, I know when you first start looking at it, Vert.X is a little different to read and it takes a little adjustment. I find Vert.X is actually very flowable for reading your code over time. And you'll find that it's much less verbose. This entire application that I implemented, as far as Java code goes, is a grand total of 251 source lines in Java. That includes all the boilerplate, that includes all the class definitions, all the import statements, 251 lines for 3 services with circuit breakers, with an event bus, completely reactive, non-blocking. And to run it and make it clusterable, normally you run a Vertex program by running a fat jar. So I would say Java -jar for the noun service, grab the noun jar. The simple case is if your machines are on a common network segment that doesn't have any firewalls or any restrictions, you just add the flag cluster when you start your application. It will use multicast DNS to discover other Vertex nodes on the same network segment, and they will start communicating and share their event bus. That's just blows my mind that it's that simple. In the OpenShift environment or in Kubernetes or in the cloud, you have to do a couple of extra steps. You have to add a library for Kubernetes discovery or AWS discovery, and you have to provide a key so that they know how to communicate and find information from the API. But it is nearly as painless. Questions? Thank you for your time. I hope it's been enlightening.
Does anyone have any other questions for this group that was up here right now before we let them leave the stage? No, we're good? Okay, I've got a change in what we are doing with the schedule because you know how we were running long in the morning? Well, we know who is long-winded because this afternoon we're running short, which is great in some ways. We've decided, I was discussing with the team, we've decided to actually, instead of doing the breakout sessions with the experts right now, we're going to take advantage of the little bit more live stream time that we have and also that you're kind of gathered here. And we're going to get the presenters, before these guys back up on stage. You guys can stick around if you want to too, but we're going to bring the presenters back up on stage. We're going to do a Q&A with the experts up here. It's going to be hosted by, if you don't know, Michael Solberg. Michael Solberg is our chief architect for the Southeast here in our commercial sales, and Michael's going to host this for us tonight. We'll spend about a half hour with Q&A. So think if you have any questions from the day that you'd really like to ask any one of these experts. We'll be taking those. And then when we're done with that, we've got some appetizers and we've got some wine. And unfortunately for our live streamers, we cannot send that over the airwaves in any way. But if you do have food and wine and beer at your desk, you're more than welcome to take it out at that point in time. But if I can ask our experts to come on the stage who aren't here and join in, and please welcome them back and welcome back Michael Solberg, or welcome Michael Solberg. Thanks.
Hey guys, thanks to everyone for sticking through the day. Obviously it's a long day and it's Atlanta, so we know about the traffic heading home. So I'm going to start out. We had a couple questions ready to go. I got the team up here. I'm missing maybe one or two people. Oh, here we go. So we'll start with a couple of prepared questions, and then we will move into kind of live audience questions. So I'm going to start with a question that I had.
Are we supposed to use those prepared answers that we had too?
No, you may not use the prepared answers. So my first question, and what we'll do is I'll just ask the question, and whoever wants to take it, if you just want to raise a hand, and we'll kind of go from there. Absolutely, yeah. So say I'm going to ask the question of the panel, and whoever wants to answer the question, I'll kind of call on them as we go around. Unless you have a specific person that you have a question for, then let me know. So actually, my first question, I was going to ask for Christian, because I was interested in the Istio thing from earlier. So the back half of today, we did a lot of talk on how to integrate Hystrix and other circuit breakers into applications that we write in the actual microservice. With the introduction of service mesh, I feel like a lot of that may be obviated. We don't need to do it so much anymore. I was curious, is it still a best practice to continue having circuit breakers in the code as well as in the mesh, or does that create some kind of conflict that we could see?
Actually, it doesn't create that much conflict. I think it's if for nothing else, at least know in the back of your mind that, yes, the service mesh in a lot of areas, not every use case, but in a lot of areas, will obviate the need for a lot of those library and framework-specific implementations of resiliency. But if you already have them in there, and if your question is, can I add the service mesh on top of that and be okay? The answer is yes, because in a lot of cases, you're gonna end up seeing that, well, the resilience at the mesh level might kick in before the resilience at the application level, or vice versa. And I guess the goal is to get resilience in your application, and whichever one kicks in, whichever one's more restrictive is going to kick in first, and you'll see that behavior first.
Perfect. And then my second question is for Jeremy. Who won the shootout?
I guess I'm gonna have to. It was me. Jason won the shootout. I'm gonna have to go with the reactive, of course, right? So Vertex won the shootout.
So Vertex, you think?
Yeah.
Yep.
Well, let the audience decide.
Audience, okay, so I want to see show of hands. Let's see. First we had, I guess the very first was WildFly Swarm. Who thought WildFly Swarm won the shootout? Oh, man. Oh. that is terrible. And then, was it Spring Boot was next? Let's see. We got the Spring Boot fans.
Well, they didn't say how many lines they had, so.
Yeah, I guess there's some metrics.
Mine was only 5 lines total.
I mean, I felt like it was the cleanest, so we'll give them a hand for that. I'm just curious, we also should talk about binary size too, right? Like how much memory did we actually take up in the deployment? How about Vert.X? Everyone likes the Vert.X, yeah. So.
Hey, all right. Better than I expected.
Yeah. Well, you kind of set it up like you'd won at the beginning.
I did say it was the best for last. So.
Yeah. Okay. We had one more. What was the fourth?
Node.
Node. Yeah, come on. Node.js. Who likes Node? Come on. Yeah.
All right.
I like Node the best, too, because it's the hardest to understand. It has the most bizarre external dependencies. And I can never keep track of it. Like, the promises thing came in, like, .6 or something. Anyway. Okay, so questions from the audience. Have I got anything you want to pass on to the team here? Oh, yeah, question.
So I'm exploring AWS and other cloud stuff. This is the first time I've heard about Openshift.
Mm-hmm.
Is it a competitor, or what exactly is Openshift?
That's great. So the question was, he's looking at, I'm assuming, hosting some applications in the public cloud, and he's been looking at Amazon Web Services, and his question was, OpenShift, is that something that plays in the same space as AWS, or is it something that is different? Who wants to take this one?
So there's a lot when you're talking about Amazon and deploying applications to Amazon, and there's a number of different things or ways you could compare those. So Amazon now has Kubernetes, which OpenShift is built on for its orchestration. So Amazon Container Service is probably the most direct analog.
They have a Kubernetes service, too.
Yeah, they have Kubernetes service, right? Yeah, so there's in preview, thank you, there you go. In preview, but there's a lot of different things. There's a lot of stuff in AWS that's not going to be inside of OpenShift. OpenShift is built on Docker and Kubernetes and other open source community projects, right? But everything's packaged up, everything's maintained by Red Hat. Instructions are available for you to help you install. You can run it on Amazon. You can also run it in other public clouds, right? So it runs on Microsoft. You can run it in Google. Where else? Rackspace.
You can run it anywhere,
yeah,
really.
Pretty much anywhere, right? So it can also serve as a layer of portability. And I know, so I'm a solution architect. I work directly with customers, and some of our customers are looking at OpenShift for exactly that reason, right? So because you can run it in your data center, and you can stand up an environment in AWS, and then you can stand up an environment somewhere else, right? So you can also then find efficiencies across public cloud providers.
Did that answer the question?
Yep.
Great. Other questions from the team here?
We must have done really well. We've answered all their questions.
We got one over here?
Why and how tools and Node.js as a platform?
Oh, sure. Yeah, that's a great question. So the question was, I think it was just kind of coming back to one of the things that we'd said earlier is, traditionally Red Hat is very much a Java shop, and so the question was, what was it about Node.js that it made us kind of decide to include it as one of the 4 runtimes in the Open Application Runtime?
I can't really answer. Oh, is it on?
I can't really answer that other than just the fact that I wanted it there. But I don't make those choices. I just pushed for it. I think it's exciting, and it's got a lot of mind share out in the market today, and I think those are good reasons to embrace it. And there's no technical reason why we couldn't or shouldn't embrace it.
Yeah, and I think from the internal conversations we've had on our internal mailing lists about it is it comes down to, from our perspective, we want to target as many developer runtimes as we feel we can reliably support. And so Node.js, Spring Boot, WildFly, and hopefully soon Vert.X is going to cover like 95% of the mind share in the developer community. We may eventually get Ruby support, we may eventually get other runtimes. As long as it's running on OpenShift, we will end up supporting those, which is a completely paradigm shift for Red Hat.
Yeah, I'll also say too, I'm probably the only person up here that doesn't come from a Java background. I come from like a C, Python background, and Red Hat has a long history of supporting runtimes based on the C library. And so in OpenShift today, in our paths, it's relatively simple to deploy Django or Rails apps. Or other frameworks as well. Somebody joked about Perl earlier, and I think that was just a joke.
There are also community-supported S2I images for things like Ruby and Django and Python and all sorts of other runtimes. I think I recently even saw an Elixir and an Erlang cartridge for it.
But I will also say, working with customers, so I work with all of our customers here in the Southeast, Node is definitely the thing we get asked about the most outside of what is our normal purview. And I think the main reason for that, the reason that people find Node so attractive is actually what came up in the demo, which is that the same things that I do on the back end, I can do in the front end. And you have a lot of developers, they're front end developers that are already going to be doing a lot of JavaScript development. They want to take that expertise and apply it to the back end. So I think that's basically why Node is one of the top 4 there.
I think something else, at least from the middleware standpoint, and you mentioned some of the other projects that we do, from middleware standpoint to various degrees of success, Red Hat has sponsored projects for Ruby, a number of different JavaScript things, Python, Clojure, Scala, a bunch of different things. And as far as the Rails side goes, there's also the Red Hat Software Collections library, which has support for pretty much whatever you want to do, starting at PHP all the way to Perl and Python and Ruby and all that kind of stuff.
Yeah, we just did a big PHP project on OpenShift for one of our clients in labs.
Yeah. Do we have a question up here? Yeah.
Well, I still want to follow through. We followed a lot of different sections of the technology and tools, but we never covered security. What kind of security tools that are out there, and what can really kind of keep you from having to keep track of all the microservices, finding out which ones are
That's such a great question. So, obviously it's in the mesh. But so the question was, we went through a lot of different code paths today. We talked about a lot of different technologies, but one of the main areas that we did not address holistically today was security. And how do we, I think there was some discussion, was it in Node where we had report on the different licenses in use?
Yeah.
And I think, we'll probably talk a little bit about the management as well, but I'll kick it over to Christian. Can you talk a little bit about security inside of the mesh?
Well, security, maybe in general, I think one of the things that Red Hat takes seriously, because our customers take very seriously, is security. And we can talk about security at all levels of the platform. So in terms of RHEL, in terms of what we've done inside of Kubernetes in the community to make things like OpenShift more secure. Things in the operating system that we've done to make OpenShift more secure. And Docker more secure. and then all the way up into the application where the end user might need facilities to do single sign-on and that kind of stuff. So we have a popular project called Keycloak that helps with that. And then once you get into the service mesh, there's going to, I suspect what you're going to see, especially as we go to a hybrid on-prem to cloud or multi-cloud type solution, I suspect we're going to start to see the characteristics of how inter-application security is going to evolve. I think we're going to go more toward what I think Google wrote a paper called Beyond Corp, and it's the supposition they have there is that when you go into these these multi-network type environments, that you just the perimeter type security that we've built for traditional enterprises is not going to be sufficient anymore. You're going to have to go with a model that more aligns with not trusting the network and involving authentication, authorization a little bit higher level than just the network. I mean, don't ignore the network, but at a little bit higher level. So I think the service mesh is in a great position to help implement some of that stuff.
Also, I know I've done some projects with DataVert where we were looking for the security and provenance of data. Do you guys want to talk a little bit about security in the data stream and how the products address that? You don't have to.
Yeah, I think to complement what Christian was saying is that one of the biggest concerns. So one of the biggest concerns with, especially in the hybrid cloud space, is security from a standpoint of having solutions that actually span multiple networks, span even multiple runtimes. And we see actually, like from customers, for example, a demand for being able to kind of spread their, basically kind of run workloads across, as I said, multiple clouds. Part of it in maybe keep their data private in their data center, but actually do processing and kind of lend computing power, especially use the flexibility of the public cloud. But then be able to kind of make sure that certain data and, like, for example, anonymized data doesn't cross the boundary, and doesn't basically get in a public, like in a public unsecure space. So part of the concerns and part of our efforts also address, like, thinking about how to secure these pipelines, how to control, how to actually build capabilities for kind of, we can call it governance in a certain kind of sense, but not in the, let's say, so much about data formats and metadata, but control over, like, sorry? Policies, yes. Yeah. And it's more about controlling what goes where, knowing, like, being able to identify the lineage of a specific data item or data set, understand where data is coming from, where has it been. Certain data has to go, for example, like, one typical example that I love giving is you need to make sure that data has been anonymized before it actually goes out there, which means that it has gone to a specific endpoint, it has been signed, and it can travel. So that's one aspect of, for example, of data security that you are thinking about, especially in this kind of distributed type of environment, right? Not necessarily data related, but I think it's pertinent to say that one of the reasons, for example, why OpenShift is OpenShift and its enterprise Kubernetes is kind of a special attention that Red Hat gives to security and making, like, creating, let's say, using the native Kubernetes support to actually create even more accessible user mechanism, like administration mechanism for role-based access, and that is another kind of an important distinction when you say, look, it's not, it is Kubernetes 100%, but there is that plus that makes it more, like, easier to administer and easier to access, right? And I know it's not a point that is related to the data question, to Michael's question, but I think it was kind of pertinent in the context and to the original question, so I had to mention.
And just to add one more thing, we've talked about a lot of the technologies we have to help you guys improve security, but from my point of view, working with Red Hat's Open Innovation Labs, is we also teach the people and process around information security. So when we do a labs residency, part of what we teach them is how to integrate information security, governance, compliance into your DevOps and CI/CD pipelines, so that a shall to remain nameless company that had an incorrectly configured struts application with a default password, if they were using our processes that we teach, the OAuth dependency check would have caught that error in their pipeline and thrown up a red flag and said, hey, fix this. Because it would have seen that there was a newer version or a version of that library that did not have any known vulnerabilities. And then we integrate, now we're starting to integrate OpenSCAP and OpenControl to do governance, even all the way up to DoD levels of FIPS 199, FIPS 200 compliance with our DoD clients. That's huge. You've probably all heard horror stories about working in federal government where it takes 6 months to a year to 2 years to get a new piece of software approved. We are working with our partners in federal government through our North American public sector to reduce that to days. That's going to be a massive win for the federal government and save you guys taxes, hopefully.
So we'll probably should just do a whole subject, a whole topic of security at the next one of these events for sure, because it is obviously something we're passionate about as a team. Yeah, I mean, we could certainly, container provenance is a whole other issue as well.
We could go hours on
we really could spend a lot of time talking about it. How about just, can I get one more question here from the audience before we break? I got anyone with a burning question here? Yes?
Actually, currently, like, we have so many cloud environments like Amazon, Google, and Microsoft. So where we are standing on Red Hat,
Oh, you just kind of, what's the advantage of maybe the Openshift paths over the offerings from the other cloud providers? Wow, that's a good question. I mean, I'd like to take that question too, but I'll turn it over to the team. Actually, you know, I will talk a minute on it because
Thank you.
I get a little bit passionate about it. You know, it's the portability thing. I think, you know, so from Red Hat, you think about Red Hat, you know, the goal of Red Hat has always been to provide a platform that can run on heterogeneous infrastructure. So if you think about the Linux platform, the main advantage of that a long time ago was, you know, I could buy hardware from Dell today, I could buy it from HP tomorrow, I could buy it from Sun the next day, and I can run Linux on all of it. And so that it kind of takes away the competitive advantage of each of the different hardware providers. Same thing in the JEE space, right? So we look at a lot of the work we do in Java. It's really to, you know, a lot of, and at one point, a majority of our Java customers were running on Microsoft Windows. And the goal of that platform is you can compile this thing and we can run it wherever it makes the most business sense or the most performance sense to run it. We see the same thing today in PaaS, right? So I have a lot of customers, certainly in my region, that have adopted. I was talking with one on Friday last week, who've adopted the Azure PaaS and have spent a lot of time porting their .NET applications up into Azure. The concern that I always hear from customers that have picked a vendor-specific PaaS is, well, what if one day the business arrangements don't look correct? I don't have that same layer of portability that I did, say, with Java EE or with the Linux operating system. And so one of the things that a lot of our customers are doing with OpenShift is it's providing that new layer of portability in the PaaS space. It's kind of the dream of Docker originally, right? Was I put it in a Docker container, I can run it anywhere. But I think what we're finding is you can't just put an app in a Docker container, it has to live inside of a platform. And Kubernetes, at least from my standpoint, has really emerged as you know, the platform that provides the most flexibility across cloud providers. So we see Amazon has a Kubernetes service, Microsoft has a Kubernetes service, obviously Google started with a Kubernetes service, and I think at one point we would have said if you write your applications to run in a container, there's a high degree of portability. I think now we're kind of looking at this and saying, wow, if you architect your applications to run within Kubernetes, there's an extremely high level of portability. And I can't think of a better way to do on-premise Kubernetes than with OpenShift. And a lot of our customers are also finding the same to be true in the public cloud. So, anyone want to add to my my passion? Thank you, guys. Great. Well, I want to thank everybody for coming out today. I think Susan might have had one or two more.
I have a question.
Yep, question, Christian.
Did you guys get value out of attending this? Was this worth your time? Yeah. Thank you. Thank you guys for
Thank you.
I do want to say, so we did this, we probably did this 18 months ago in the same venue. We did it again this year. We're definitely going to do it from here on out. We really appreciate everybody coming out to talk microservices with us. We'll pick up the security topic for the next one for sure. And then reach out to your Red Hat team if you have any other topics you'd like to see us address in the future. Oh, yeah, go ahead, Jeremy.
Yeah, so if you have not registered at Red Hat developers, developers.redhat.com, it's completely free. A lot of the assets we showed off, books written by some of these guys, are on developers.redhat.com. You can download the PDF, some of the same books we have in the back. Right, and articles, most of us write articles and publish articles on there. A lot of great links to stuff, plus you get access to download all the bits and stuff like that too. So if you don't have a membership, developers.redhat.com.
Awesome. I will tell you that there was a lot of work from this team that's on the stage and other participants in putting this together, because we put this together with our Southeast, or Atlanta and Southeast customers in mind. So it's very customized to your needs. So I'd like to thank them for all the time and effort that they put into this. We're hoping that we can take this on the road with your feedback. Being able to refine this, we'll be moving it into other locations, and maybe some of your colleagues that aren't here in Atlanta will be able to take advantage. So I would say that make sure you fill out your surveys that are here on the tables. I'd like to thank the people who are on live stream for being with us today. Wish you were here. But we're glad that you're here in some way with us. For those of you who are here in Atlanta, know that we still have the parking stickers in the back. Know that we have some books in the back as well for you pertaining to microservices. And in particular, Christian Posta, I know, has a book up there that he had authored. I think we may have one other. Do we have another person's book up there? You can take a look, and those are gifts to you today. And then we have our containers. I'm going to plug. We have our Container and Cloud Native Roadshow, which is the new improved Red Hat OpenShift Roadshow. You got a card, but it didn't have specifics. For those of you who are still with us, in Atlanta, April 11th, mark your calendars. That's hot off the press. We don't have a registration yet, but if you take the card that was at your seat, and if you go there and look within the next 2 weeks, we should have registration up and running. We'll be able to accommodate probably about 40 to 45 people at that one. We're hoping to have another one after that. We have beer and wine in the back. We'll have food shortly, too. We thank you so much for being here with us, and we hope that you take a lot of this goodness back to your work and to your colleagues, and let us know what else you would like to see here in the Atlanta area and beyond. Thank you.